Okay, welcome. So we have been working with apply functions and seeing how we can use them to construct bootstrap distributions from which we can get bootstrap confidence intervals. So in the previous video, we set up this bootstrap underscore CI function using the lapply function to create 10,000 bootstrap resamples and for that we then use to estimate a population mean. Last week in the previous module, we talked about loops and we came up with a for loop for this process as well. So I've got the code for that over here. And so what I'm now defining is a bootstrap confidence interval via a loop. So I'm going to call this loop underscore boot underscore CI. And this function takes a sample, a statistic. So here we could use different statistics in this function, like a mean or standard deviation or et cetera. In the code that we have up here, we fixed the statistic to be the mean, but we'll set the stat to be mean. And then we have a confidence level and the value for the number of bootstrap statistics we called capital N. And I'm going to set that to as a default value of 10,000, which is the same value that was used over here. So what this is doing is it's saying create a numeric vector boot dist where we're going to store the bootstrap statistics. Let's calculate the length of our sample. And then we're going to go into a for loop from 1 up to the upper, to the last bootstrap resample, which is capital N. We pick a sample. We calculate some statistic of that sample. For us, it will be a mean. And then we're going to go ahead and find the cutoffs using the quantile function. So very, very similar to this command over here. We had 2 steps: pick a bootstrap resample, find its mean, and then we just needed to unlist it before we could calculate the quantile. So hopefully the code looks very similar. How it's being executed, just the syntax is different because here we're using a for loop. So I'm going to run this code cell. This is going to create this function, but that's all it does. If I want to check to make sure I'm getting consistent output, I'm going to run this function with the input where the vector where my chick weights are stored is WT, and we're going to apply the statistic mean. We're going to do a bootstrap distribution for the sample mean, but we'll use the default 95% confidence interval and the default 10,000 resamples, and we get the same exact confidence interval as the prior function. So we know that these functions are working consistently. The question is, how do the efficiency of these calculations work? So to compare these speeds, we're going to use the micro benchmark package. So if you've already loaded and installed this package, you don't need to run this code cell. If you haven't, then you'll want to uncomment these commands out and then run the code to load them. What micro benchmark is going to do, it's going to create 100 bootstrap resamples using my loop. It's going to create 100 bootstrap confidence intervals using the lapply function, and then going to compare the speeds. So I'm going to run this code cell. It will take a couple of seconds to run, so I'm just going to pause the video while this runs. But you can see things are getting moving. It's playing as we speak. Okay, and that code cell took 37 seconds to run in Colab for me. And what I can see is that it ran each of these commands 100 times. So it created 100 bootstrap confidence intervals using each of these methods, and then looked at the distribution of time. So this is like a 5-number summary: the minimum, the first quartile, the median, the third quartile, and then the max value. So if we compare means, actually the loop that we wrote is more efficient than the lapply function. So that might surprise you, but they're pretty close. They run fairly close speeds. Again, the loop that we wrote actually is a little bit more efficient than the lapply command. The lapply function is using loops. That's why they're pretty similar speeds. But again, the other consideration that you might want to have is which code is more elegant, which code is more concise. And again, it might be close here, but just want to compare two different methods for getting the same result. Okay, so that is a wrap on some of these initial apply functions. Next up, I want to talk about my personal favorite, the tapply function.